Do you like candles? How about the scent of oranges? Then you will love orange scented candles. Using a special ingredient called octyl ethanoate, you will be able to peel the burn once you light up your candle. An ester is formed when an alcohol is combined with a carboxylic acid with a catalyst. Alcohols have a hydroxyl group at the end of a carbon chain, and their names end in OL. So for example, octanol is an alcohol. Carboxylic acids contain a carboxyl group, and their names end in oic acid. So for example, ethanoic acid is a carboxylic acid. Together, they form an ester. And esters are similar to a carboxylic acid, except that the hydrogen in the carboxyl group is replaced with an alkyl group, and their names end in ate. So for example, this ester is called octyl ethanoate. Octanol and ethanoic acid combine to form octyl ethanoate and water. This reaction is slow and reversible, which means that the catalysts, such as heat and sulfuric acid in this case, are added to speed up the reaction. Sulfuric acid is also a dehydrating agent, which helps yield more ester, because this reaction is also reversible. To form the water, the alcohol gives a hydrogen atom, while the carboxylic acid gives a hydroxyl group. And this forms H2O, which is water. The ester is formed when the alcohol's oxygen atom joins the carboxylic acid's carbon chain. And there we go. That is the ester. To create that orange smell in the candles, a special ester was used called octyl ethanoate, which gives oranges their smell. Now, before creating this ester in the lab, some safety rules must be followed. Firstly, safety goggles were worn at all times to protect the eyes from chemicals. These chemicals were not directly sniffed as they are wafted because they could be dangerous to inhale. Chemicals were not touched by fingers because there are some acids that could cause some damage to the skin. And skin or eyes that were splashed by chemicals were washed thoroughly for at least 20 minutes. Now, the materials that were used to create octyl ethanoate goes as follows: a 600 milliliter beaker, a ring stand, a hot plate, a thermometer, test tube tongs, a test tube holder, a test tube, 3 plastic pipettes, octanol, ethanoic acid, and concentrated sulfuric acid. Now, for the procedure of synthesizing octyl ethanoate, a 600 milliliter beaker was half filled with tap water. The beaker was surrounded by a ring stand on a plate, and the hot plate was turned on to full until the water boiled. A thermometer was placed in the beaker of water, and the heat was reduced to maintain the beaker of water at 80 degrees Celsius. So basically, a hot water bath was created. Using a plastic pipette, 20 drops of octanol were added to the test tube. Using another plastic pipette, 20 drops of ethanoic acid were also added to the test tube. And using the last plastic pipette, 2 drops of concentrated sulfuric acid were added to the test tube. This test tube was placed in a hot water bath for at least 20 minutes to let the ester cook. After 20 minutes, the test tube was removed from the bath using tongs because it is hot. The test tube was placed in a test tube holder And once it cooled, the test tube was shaken, and the vapor of the octyl ethanoate was wafted to identify it, to get that orange smell. Congratulations, the ester has been synthesized, and now it's time to isolate, purify, and identify the ester use for commercial use. In this case, using it for an orange scented candle. So the first isolation method is to use a method called extraction, which is when all of the chemicals are poured into a separatory funnel. The ester will form a layer on the top of the mixture because it is immiscible in water, because it cannot form hydrogen bonds, and it is also less dense than water, meaning that it will float at the top while the aqueous layer will float at the bottom. And then the aqueous layer will be drained into the flask until it reaches the ester, removing all of the aqueous layer but leaving the organic layer, or the ester. Next, we must purify the ester. And that is done because there are going to be some unreacted reactants left in the mixture still. So the mixture will be boiled, and the compounds with the lower boiling points will become a vapor and condense through this little pipe, I would say. And this will leave the octyl ethanoate in the flask. So because octyl ethanoate has the highest boiling point out of the three other compounds, it is going to evaporate or become a vapor last. So if this flask was boiled at a degree between 195 degrees Celsius and 211 degrees Celsius, then the water, octanol, and ethanoic acid will all become a vapor and leave behind the octyl ethanoate, which is going to purify it basically. And once it's purified, there must be a way to identify it to make sure that it is the intended product. And there are three ways. The first way is called nuclear magnetic resonance spectroscopy. The second way is called infrared spectroscopy. And the last way is called ultraviolet spectroscopy. And these three ways combined will help determine the characteristics of the ester. And once that is done, then the ester will be readily available to use for the candle.